So today what we're working on is the forms of the quadratic function. How do we know what we're doing today? We're basically going to expand, complete the square, and factor quadratics, and go backwards as well. How do we know we understand? We can simply convert to the desired forms. Now, there were three forms that we've actually studied in this unit. We lately just studied the vertex form, which is this, where the vertex was described as, the vertex was PQ. Remember, anytime we have x minus p, it's the opposite of what we have for p. And then we also took a look at the standard form, which is where we all started at the very beginning of Unit 1. And when we were in Unit 1, we studied the intercept form, which involves sometimes common factoring, regular factoring, and factoring difficult trinomials. Now what we're going to do is we're going to move up to the next portion of these equations. We're going to talk about how all these forms come together. Now, we're going to draw a little diagram that shows what processes are used to convert from one to the other. So, to go from standard form here, y equals ax plus bx plus c, that involves us doing factoring. Now going back from intercept form to standard form, all we're going to do is expand the entire equation. So expanding really means something like this. A goes into A and R. A goes into X and R, which then eventually will be multiplied by X and S. We'll take a look at that today when you're doing your practice. To move from standard form to vertex form, we learned a new thing called completing the square. Now, to undo the vertex form, all we have to do is we expand and collect like terms. When we want to take something from vertex form, when we want to take something from intercept to vertex form, what we do is we get the x-intercepts and then average them and then find y. We did that 2 days ago. Now, in order for us to get from vertex all the way to intercept form, literally what you have to do is you have to take your vertex, convert to standard, and then go to intercept form. Basically, you're going to expand, and then you're going to factor to get the intercept form. Example 1, given the equation, right? Y is equal to 2, x plus 1 squared plus 3, write the equation in standard form. So I'm going to write out how I want it done in each section. So standard. Taking something in standard form, just before we talked about it, it said we had to take it from vertex form, which this is, and in order to undo what we've done, we're going to simply expand to get something that looks like ax squared plus bx plus c. Now let's get back to our calculations. Based on this, what we're going to do, we're just going to quickly do our standard form. So in order to do that, we basically take our equation y equals 2x plus 1 squared plus 3. Then what we're going to do is we're going to rewrite it to its expanded form. X plus 1 is the same as saying x plus 1 times x plus 1. And then plus 3. Now what we're going to do is we're going to distribute the 2 into the first bracket, and then we're going to leave it in the brackets on another line. So that's 2x plus 2, and we leave it in a bracket. And then we still have x plus 1 to still work with. So now what we're going to do is we're going to take the 2x plus 1, multiply it in, and then we're going to do the same for the 2, and we're going to drop our brackets immediately. This is the form you do it in order to save yourself some time. So we get y is equal to 2x squared plus 2x plus, and now we're going to multiply the 2 into the x and the x plus 1, so we're going to get 2x plus 2, and notice all the brackets are dropped because we've distributed everything, and then we have plus 3. Now we have to collect our like terms, which is y is equal to 2x squared plus 4x plus 2 plus 3, which is 5. So this is our standard form. Now we're going to go and take what we have for our standard form, which is this thing here. And what we're going to do is we're going to expand it. We're going to go and factor it. So this is going to be the intercept form. So let's do that now. So now we're going to try to find this equation. Y is equal to 2x squared plus 4x plus 5. So I need two numbers that multiply to 10 but add to 4. There's no easy solution, so we're going to have to use quadratics. When we try to find this, we'll notice that there aren't any factors for 10 and 4. So before you do anything, you want to check to see if the following, if we have one or two roots. So we check b squared minus 4ac. And we'll plug these numbers in. Plugging that in, we're going to have 16 minus 40, which is negative 40. Therefore, there are no roots, which means there's no intercepts. If there were intercepts, what we would do is we would just simply go and factor this using the quadratic formula. But since we don't have any, we move on from there. Last but not least, we have to determine all the information we can from these equations. So in the original equation, which is in vertex form, that means here the vertex is negative 1, 3. And for this graph here under the standard, we can easily find the y-intercept, and we find that the y-intercept is 5. So remember, we said yesterday that all we had to do was read this last number to interpret what our intercept would be. Now, if we had found a factored form for this equation here, then we would have had to say the x-intercept is this and something else. Now on to the graph. So we're just going to quickly sketch the graph here. Our vertex was -1, 3, so I'm just going to put the point here. Our y-intercept is 5, so I'm going to assume that 5 is here. Now, if I want to find another point that matches it, notice, if I drew a line directly through the vertex, we would have an imaginary mirror, and all we'd have to do is match the point that is here across to the other side of the mirror. In this case, we have to go 2 over. Notice we went from here to here, that's 1. So now we're going to have to go to the right 1 and then up to the 5th position to find our extra point that we need for our graph. So in this case, we have our graph opening up and going through our vertex. And this was y equals 5, and then this is the point -1, 3. There's our constructed graph, and we're done. It's just a little sketch. It's beautiful, isn't it? So now we have another graph. We have an equation that is in standard position. We're going to have to convert it into intercept form, and we're also going to have to convert it into vertex form as well. To convert it into intercept form, what we have to do is we have to actually factor it. To make this easier for me, I tend to pull out a minus sign so that I can easily factor. So now I need two numbers that multiply to -3 and add to +2. And they are x plus 3 and x plus 1, which means that my intercepts, my x-intercepts are x equals -3 and x equals +1. So those are what my intercepts are right away. The next thing that we have to do is we have to calculate our vertex form. That's great.
So you're crazy.
Yes, I am.
This peel with brownies. Okay?
Okay.
Got it?
So now we're going to compute our vertex form. Take our original equation, -x² minus 2x plus 3. First thing we're going to do is we're going to say y is equal to -x² minus 2x in brackets plus 3. We now factor out a -1, x² plus 2x, and now I'm going to skip a step. No, plus 3. So now we know we need a number that we're going to take 2 and we're going to divide it by 1. Plus 2 divided by 1 squared is equal to 1. So we're going to add 1 and 1 inside the bracket. So we're going to get y is equal to -x² plus 2x plus 1 minus 1 plus 3. Now, upon simplification, you end up with -x plus 1 squared. You can work through this. And then we have plus 4 as our final answer, which means our vertex is -1, 4. And we can plot this on the graph here. Looking at the original graph, you'll notice from one of our previous classes that if we had a negative on the x² term, the graph would be opening down. We also know that our vertex is -3 and 1. Sorry, our intercepts are -3 and 1 for the x-intercepts. So let's go and plot those right away. And based on our original standard form, you'll notice that that 3 is our y-intercept. So, just like before, if I drew a vertical line through here, I could find another point. And that other point is this one. Notice it's 1 over away from the vertical, from the vertical of the vertex, and that other point is right here. We're going to block it in as red, and then we'll quickly sketch it. In a moment, what I'll do is I will calculate the last graph for you, and I'll explain as I go along what has to be done. First of all, this graph is already in intercept form, so we're going to turn it into standard form right away. And now we collect like terms. Based on our standard form, the y-intercept is -16, so it's way off the graph. Now we're going to take our standard form and we're going to calculate the vertex form. No!